Okay, so the biggest difference between 5.1 and 5.2, 5.1, it was mostly just, here's a number, take it to a power, so you multiply that number over and over. When you put the variables in there, everybody keys in on the variables and you kind of forget about the coefficients. You forget about the numbers as you're going through these. So here's the biggest thing you have to do when you get one like this. We'll go through some different examples here. You get negative 8 x to the third y. We're going to take that whole thing and take it to the second power. Okay, now, and kind of like we said before, if you have a variable that doesn't have a power on it, here's kind of what you want to think, and we'll write it out to the side here. The y didn't have a power, so you want to go back and put a 1 on that one, so it's y to the first power. You also want to go ahead and think that this is really negative 8 to the first power, because there is still at negative 8, that if you actually wrote this out, way back like you would have done way back when, you would have taken negative 8x to the third y and multiplied it by negative 8x to the third y, which you could do it that way. But they're saying, all right, here's kind of the shortcut you can do. You can just take this 2 that's here, and it's almost like distributive property. You can do 2 times this power, 2 times this power, and 2 times that power. You just have to remember that anything that doesn't have a power, number or letter, variable, you've got to go back and put a 1 on it. Okay, so whether you think about it this way or this way, you've got negative 8 times negative 8, that's a positive 64. For this one, 2 times 3 makes that x to the 6th, and for the y, 1 times 2 is 2. And that would be your final answer that you get for that one. And again, it's the variables, usually everybody gets those. Even the ones that don't have the power, they'll remember to go back and put the 1 here. The coefficients, the numbers are always the ones that get left out. It's just, I guess it's just human nature. It's just kind of easy to do that. Even the people that's been doing these a while, that's the ones that we always make mistakes on if we get in too big a hurry and try to do too much too fast. All right, even if you have fractions, it still sets up basically the same way. Give me negative 8. Oh, that's fine. We'll leave it there. So we've got negative 8z over y cubed, and let's do that to the second power. Actually, let's make it third power. Okay. And again, technically it's negative 8 to the first. It's still z to the first. So then you would take the 3, multiply it to every single power that you have. Even the powers in the denominator, you're still going to multiply it by 3. Okay, so, and again, when you've got the negative 8, it's negative 8 to the third power. And we'll go back and multiply that here in a second. We got z to the third. And on the bottom, 3 times 3 would be y to the 9th. Okay, and then using calculator, using whatever you got, go back and do negative 8 times negative 8 times negative 8. That's 512 negative. Okay, so they give you a couple of those, kind of get you thinking about, all that you're doing is taking that power on the outside and distribute it out to all the powers on the inside. And then after you've got a couple of those, kind of get under your belt, then they'll say, all right, well, let's kind of combine these problems with the problems we had before, where you're going to take this number and multiply it by this number, but one or both of these might have power mixed in with it. So we'll do 2x z to the third squared times 3x to the third y to the third z squared. Okay, so first thing is, where you've got the power to a power, you got to go back and multiply this 2 times everything. And again, we don't have a power with the x or the 2, so we got to go back and put 1 there, basically. So we're going to take this 2 and multiply it by all the different powers. Okay, so we've got 2 squared, which would just be 4. We've got x squared, and we have z to the 6th. And then we're going to multiply that by, which we haven't done anything with the back set of parentheses yet, z squared. Okay, so once you've taken the outside power that's on the outside of the parentheses, distribute out to everything on the inside, now you're back to the rules that were back in section 1, where now there's no powers, now you're just multiplying the first expression times the second one. So then you're just going to take and multiply 4 times 3 to get 12. And then for the x's, you got x squared and x to the 3rd. That's where you're going to add those together. 2 plus 3 would be x to the 5th. For the z's, z to the 6th and z to the 2nd. So it'd be z to the 8th. And there's only the one y that's back here, and if there's nothing else to put with it, well, then it just stays just like it is. And somebody's probably thinking, does the order matter? No, in this case, order doesn't matter. You know, whether you put the y to the 3rd first, or the x to the 5th last, or the z to the 8th, it doesn't matter. As long as you've got the right number with the right power, where you put it in that list of numbers, it doesn't really matter. The only thing they normally will do is they'll put the coefficient first. After that, it doesn't really matter. Most of the time it's alphabetical order, but if you don't put alphabetical order, it's really not a big deal. As long as you have the right numbers with the right powers, that's really all that you worry about. Okay, and then the last one they look at out of section 2. It's where they go back to the division from back in section 1 and bring it to a power. So now we've still got the same thing. We're going to raise it to a power, but you've got this fraction on the inside that we've got to work with. Okay, now you could go back and do distributive property with it first. You could do, put a 1 here and make it 5 to the 4th, multiply that out and get it to 625. You could do 10 to the 4th and make it 10,000. But then you got to simplify that number, which we don't want to do, right? So before you do this power, if you've got anything on the inside you can simplify, go ahead and do that part of it first. So with 5 and 10, you can divide those both by 5 and make that 1/2. So we've got 1, and then we may have placeholders. We'll hang on that one for just a second. You've got m to the 5th and m to the 2nd. Sorry, n to the 6th and n to the 2nd. So you can subtract those 2 and make that n to the 4th. So we've got 1, m to the 5th, n to the 4th, and that's going to be over 2. So do everything you can on the inside of the parentheses, break it down as much as you can, and then we've got it to the 4th power. Well, with the 1, it's in the top. We've already got this other stuff, so if you do 1 to the 4th power, it's not really going to do anything because it's just 1 times 1 times 1 times 1, so we don't really need the 1 in the top. So now we can go back and actually multiply out the exponents here. You've got 4 times 5, which would make it m to the 20th. 4 times 4 for the n, which would be n to the 16th. And then for the 2, again, it's going to be 2 to the 4th power. So if we've got 2 to the 4th power, 2 times 2 is 4, 8, this should be a 16 for the number that would be there. Okay, and that kind of goes back to like order of operations, that anytime you can do something on the inside of the parentheses, you normally want to do that as much as you can because it'll make the work easier as you work down the road. So, in this one, you could have done, for the end, you could have done 6 times 4 and gotten 24. You could have done 2 times 4 and gotten 8. But then you'll subtract 24 and 8, and you'll get 16. So, how you get there with those, it's not that big a deal. But with the numbers, it really would be a lot easier to simplify it first because it makes these numbers easier to do because the numbers are smaller to take to the power. Okay, so and we'll put 5-2 and 5-3 together because that was it for 5-2. It's just a little spin off of 5-1. Just playing around with the different powers and the different exponents there. Okay, all right, 5-3. And we kind of jumped the gun back in section 1 when I got off on the negative exponents. This is where we'll come back in and do more with the negative exponents here. That 5.3 is pretty much all just negative and zero exponents. Okay, so kind of stole the thunder, and again, kind of got off on the sidetrack and jumped ahead, but that's okay. Okay, so you already kind of know this one because we talked about it a minute ago. With the zero exponents, again, anything to the zero power is 1. So very first thing they're going to start you off with is something like this, where you got 3 to the 0 power. Okay, again, anything to the 0 power is 1. Got it. Now, even if that's a negative number, it could be negative 4/5. It could be a negative fraction to the 0 power. Doesn't matter. If it's anything to the 0 power, it's still just 1. Okay, now here's where they kind of start tacking on a little bit extra to it. What if it was 2 times 3 to the 0 power? Again, here's where you go back to your old order of operations where you do the parentheses first, which we don't have any. You do your exponents next. So you've got 3 to the 0 power, which is 1. So now we've got 2 times 1, so that would make it 2. So that's when they start kind of showing you, okay, just because you have 0 power, it doesn't automatically default to 1, because there may be other stuff that you're going to do where you're going to multiply it, divide it, add it, subtract it, that you could change it, you can do something to that number. But that particular part of it, for that part is 1, and then we can do other stuff around it and kind of go with it there. Okay. Here's one that kind of gets a little bit sneaky sometimes. Negative 4 to the 0 power. Actually, let's do it this way first. Let's do negative 4 parentheses to the 0 power. Still something to the 0 power. Doesn't matter what it is. That one would just be 1. Okay, here's where they get sneaky. It's negative 4 to the 0 power without parentheses. Okay, if they don't have a parentheses around that one, the negative basically, if you do one like that, it's basically thinking about it this way, that the negative goes on the outside. So without the parentheses, it's really the negative of 4 to the 0 power. So that actually would be negative 1. So this is one of those where if you have a negative with or without a parentheses, it does make a difference in the answer when you go through this thing. Because in this case, it's the whole thing to the 0 power. For this one, it's just the negative of 4 to the 0 power. So you're doing this part first, and then you go back and throw the negative in there. It's kind of like when we were doing it before, if you had the negative of 2 squared, you do the exponent first, then you go back and put the negative in. But this would have been like negative 4, where if you put parentheses around it, it's negative 2 times negative 2, it would have made it a positive 4. So they're kind of going back to that one in the very first part of the section back there and kind of bringing that one back in. Okay, so that's kind of one of the first problems they give to you. Have you go through that? Let me give you one more here. Let's do negative 2 times 6 over 7 to the 0 power. Okay, and again, it's almost like order of operations. You've got the 6 over 7 with parentheses. It's raised to the 0 power, so you're going to do that part of it first. So that's negative 2 because you've got this to the 0 power. That part becomes 1. And you can almost think about there being like a dot here for multiplication. Even though it's not there, you can really think about it being as negative 2 times that. So really it's negative 2 times 1. So that would be just a negative 2. Okay, so bunch of, and they're going to throw some different zero exponent questions at you. Make sure you got it. Make sure everything is good. I did a bunch of extras just because sometimes with zero power, I think everything, almost all the questions that you'll get on ALEKS, you have to master, I think, 3 in a row of a certain type of question. Once you're good with that one, then they move on and kind of let you forget about it for a little bit. And they'll do knowledge checks like every week or 2, week and a half, something like that, where you have to go back. They almost like give you little review questions you have to kind of go back and do as we're going through those. Those should be cut off when we get to a test. If for some reason it's asking you to do a knowledge check when you're trying to do a test, just shoot me a text or shoot me an email real quick and say, hey, can you turn off the knowledge check for me? I'm trying to take this test, and I can click a button and take it off for you. It's supposed to. Sometimes it always doesn't work exactly like it's supposed to, but most of the time it's pretty good about keeping those away from you. Okay, so pretty much the next, I think 5 or 6 questions, they almost all kind of do the same thing. Again, with either zero exponents or negative exponents, where they're going to tell you, all right, take this problem we've got and rewrite it without an exponent. Just give me a number with no powers at all in it. Okay, so first thing it's going to do is going to go back to what we were talking about when we jumped off topic there in section 1, or jumped ahead really. That if you had 6 squared, that'd be 6 times 6, which would just be 36. So the only difference between 6 to the second power and 6 to the negative 2 power is that when you have the negative 2, that really means it's 1 over whatever it was for 6 squared. And a lot of times that's the way the book is going to show it, is they're going to show you, well, if you've got a negative exponent, that's really going to be 1 over 6 squared. And then 6 times 6 would be 36. So the key thing is, if it's a negative number, again, it basically means the answer needs to be fraction. All right, same directions on all these. They're going to ask you to rewrite without an exponent. Just so we don't have to keep rewriting the same directions, we'll go back and do it here. So we've got 3/4 to the negative 1 power. Okay, now if it was 3/4 to the first power, you're good. Because if it's the first power, it's just a number, you're good there. The only thing with the negative means that it's upside down. Everything's in the wrong place. So it's 3 to the negative 1 and 4 to the negative 1, which basically means the 4 is going to go up here, and then the 3 is going to go down there. And and what they're trying to do is they're saying, all right, if you think about this one where we had 6 to the negative 2, to get rid of the negative exponent, we just drop it to the bottom. Now, if it's already in the bottom, it's negative, then you just move it to the top, it takes off the negative. So anything with a negative exponent means it's in the wrong place. You got to move it either top to bottom or bottom to top. Okay, if it's negative 6 to the negative 1 power. All right, well, there's no top or bottom on this one, right? So again, technically, if you want to make this a fraction, you could technically put it over 1. So all we're going to do then is it's negative 6 to the negative 1 power. We're going to move that negative 6 from the top down to the bottom. And again, you have to have something in the numerator, so then you go back and put a 1 for a placeholder there. So it would be 1 over negative 6. Okay, now, and the big thing on that one is, here's what they're trying to get you to see on a problem like this. Don't confuse the negative that's here with the negative that's here. Because if the negative number is in front, it doesn't impact anything exponent-wise. The only time you move stuff from one numerator to the denominator or back and forth or vice versa, it's always the power that's up here. This is just a positive or negative. You don't worry about that one. That doesn't impact the number at all as to where it's going to go. It's just this part that moves this thing up or down. Okay, we'll do w to the 7th to the negative 2 power. Now, the one thing they'll do different with this one is, because it's a variable, you're going to have powers. Like, there's no way you can get rid of the powers because there's no numbers on this one. So this one, they'll tell you to rewrite it without a negative exponent. Okay, so first thing you'll do, again, you've got to go ahead and do distributive property that you got to get rid of the fraction here. So go ahead and do 7 times negative 2. That makes it w to the negative 14. And similar to the one that was back up here, that if we'd had, for this one it was just negative 6 to the negative 1 power, just means we've got to drop that to the bottom. Same thing here, we're going to take that w to the 14 that's on the top, put it on the bottom. And since there were no numbers or anything else, we'll just go back and put a 1 for a placeholder. Okay, and basically the same directions on this one. They're going to ask you to write it without negative exponents. Okay, now there's no like terms in there, but there's no fractions where we've got anything where we've got any parts of this one. So all you're going to do is, again, you're going to go back and just remember that, again, that's still 3 to the first power. You're going to take this negative 4 and multiply it to all the different powers that you have here. So it's going to make it 3 to the negative 4 power. With a w, you've got negative times negative, so it's a positive 20. And then for the x's, negative times negative is a positive 8. Okay, now once you've done that, if something is positive exponents, it's done. So the w20 is good. The x to the 8th is good. But this 3 to the negative 4, that part's got to go from what would be in the numerator, move it down to the denominator. So it would be basically 3 to the 4th power. And from there, they should make you go ahead and go one more step. All right, now that you've got the negative exponent that's gone, go ahead and do 3 to the 4th power. So 3 times 3 is 9, 9 times 3 is 27, 27 times 3 would be 81. So that would be w to the 20, x to the 8 on top, and then 81 would be in the denominator. Okay, and then the last one out of section 3. Okay, and this one's got a couple of different routes you can go here. Because on the inside of the parentheses, we got p to the negative 3 and then p to the negative 6. You still got the negative 2 on the outside. And again, the one thing you want to think about that's not really here is that it is technically 4 to the first power. Okay. A couple options you can do. Everything on the inside, you can always kind of work on that one to see what you can do. Now, because these are negatives on the inside, and here's where you have some different options on what you want to do. That p to the negative 3 that you have on the top, because it's negative, you can move it to the bottom. The p to the negative 6 that's on the bottom really means you can move it to the top. And then the 4 to the first power, it's positive, so it's good. It'll just stay right there. Okay, now that you've got positive exponents on the inside, and that's really kind of one thing you want to do, is that if you've got negatives on the inside of the parentheses, similar to the problem we did before, you know how we had the fraction, you could do some simplification on the inside. It's better, it's always a lot easier if the numbers are positive. So if they're negative, go ahead and move them around and get them where they need to be. Now you can actually subtract these two. You've got p to the 6th and p to the 3rd. Well, you can subtract these two numbers and make it p to the 3rd, but since the p to the 6th is on top, it's going to leave you p to the 3rd on the top. 4 is on the bottom, and then we've got our negative 2. And again, technically still that 4 is the first power. So don't forget about it. It's easy to forget about it sometimes. Okay, now you've done all the work you can do on the inside. Worked it around, moved it around as much as you can. Now all you're going to do is multiply the negative 2 times here, and negative 2 here. So it's p to the negative 6, and 4 to the negative 2. But again, because they're both negative exponents, we're going to have to move the p to the 6 to the bottom. And moving it makes it a positive exponent. Same thing with the 4 negative 2. Move it from the bottom to the top, which makes it positive. And then you can do 4 squared and make it 16. Okay, now, and this was one of those weird questions where we want to kind of stick to a pattern, because somebody may say, well, could we have just done everything times negative 2 in the beginning? Sure. And it would have been fine. Because you had negative times negative would have made that a positive 6. You know, negative times negative would have made that a positive 12. And then you would have had 4 to the negative 2 power. Okay. And then you could work it around and subtract the exponents and move the 4 to the negative 2. You'll get the same answer. It just sometimes it's easier one way than the other. You know, if you're not sure, I would always tell people, work on the inside as much as you can, get that down as far as you can go, and then go back and distribute out the power. So it just depends on the question and how you kind of roll through those. That's exactly what you want.